All right, let's get started again. Although, let's do one quick double check. So tomorrow we have a discussion session we need to go to. There's some tutoring that I guess I could go to for Physics 105. And there's the 105 discussion, okay. Yeah. All right, let's get started.後で参考にするからこっちに置いといて。All right, so okay, it's okay. Okay, that had a mini heart attack there. Getting kind of やるのめんどくせえ。What did we even cover today? Okay, what should I do? Alright, so that's one down. I think I got an email from someone, so let's check that as well. Oh, Minnie, welcome back. How are you doing? Let's actually move this off screen. Let's... I'll address that later. Alright, so, let's see, what should I do? And technically the thing on my mind is getting that art done, but let's see, so... We got... Alright, so we got discussion at 2 to 3, then there's off... I don't really think I'm gonna go office hours. And then discussion from 4 to 5 tomorrow. And then after that we got the homework assignments for both classes. Okay. How do they look? Doing good? Yeah, I'm, well, I'm honestly behind on a lot of things, but, let's see, this was uploaded Friday. Yeah, so it must be this assignment then. Okay. Non-uniform mass density. Okay, it's constant density 0. Interesting, we got formaldehyde, okay, yeah. Oh, so this is where you'd actually use the point mass description, okay. Compton generator, what is that? But yeah, just forever swamped in assignments, you know, the usual. Where did I put the textbook? There it is. Nine, 3, 1. 931. Oh, okay, here we go. A narrow glass tube in the shape of a torus or ring, filled with water plus some dust particles to let one see any motion of the water, okay? The ring and water are initially stationary and horizontal, but the ring is then spun 180 degrees about its east-west diameter. Explain why this should cause the water to move around the tube. Show that the speed of the water just after the 180 degree turn should be 2 omega r cosine theta. Let me look up what the hell is a Compton generator. Oh, okay, so it's set up like that. honestly not quite sure, but back I was updating Twitch. Okay, okay. Cool. Well, yeah, welcome back. Hollow glass ring tube shaped like a donut, inside of which is filled with water. If the ring lies flat on the table, the water in the ring is stationary and then turned over by rotating itself 180 degrees about a diameter, or around a diameter, such that it lies flat on the table, which is horizontal. The result of the experiment is that the water moves with a certain constant drift velocity around the tube after the donut has been rotated. If there were no friction with the walls, the water would continue to circulate indefinitely. So it's supposed to be a good demonstration of the Coriolis force due to Earth's rotation. Oh, I forgot to go buy tea again. No, whatever. We can crack open another bottle of or another can of sparkling water. Let's see what it is. Have you heard of have you heard Ibn Coconut Mall? Everyone? Probably not. Sorry, I don't know what you're talking about. So I guess the answer is no, I haven't heard of it. Sorry, what is this notification? Oh, I got someone's subscription. I don't know. Yeah, hydrate. I'm honestly not a fan of the sparkling water, but you know, it's liquid. We can drink it. No biggie. Okay. I spelled it right, but apparently no one has a video about it. That kind of sucks. Maybe if I just put in Compton Ring. As long as it's edible. Right, yeah, like like it's in a can, so you're not gonna deal with like plastic leaching into the water or anything. So I'm not really gonna complain. I guess I will complain, but I'll still drink it. Yeah. Okay, I really don't get what this is supposed to be doing. If anyone can give me an explanation for what the hell a Compton generator is doing, feel free to explain the dynamics of quantum mechanics. No, let's just no. We're not fussing ourselves or fussing with anything. These are actual problems. That's not something on Slater about the Compton gen. Oh, it's it's literally this question. But okay, it means we get a diagram. So you probably really shouldn't rely on Slater for everything, but we'll at least rely on it for this diagram. Okay, so it's a torus-shaped tube filled with water on the surface of the Earth. When spun through 180 degrees around its east-west... What does it mean by east-west axis? I guess the first thing. I mean, I guess that's all... I mean, I just taking it at face value, it must be whatever the... That one line, that one axis that goes literally from the east side of the object to the west, like in a straight line, is... Must be the east-west axis, but what's the point of that? I guess that's these dotted lines that they have in the... Or you guys can't see the diagram, but there's a sphere with some dotted lines that are... that look like you could, like, you know, cut the earth in like a... in like, you know, like horizontally. So I guess that's what these dotted lines mean. You know, it means that they're... It's kind of... That's the direction, or like the kind of general what it's doing. Alright, so when you spin it 180 degrees around that axis, water starts moving around the tube, right? But so like if I was literally holding one right now, and supposing east and west is like to my left and right, we want to spin it 180 degrees around that thing. So it's literally like if I had like if I was holding it like a donut, then I'd literally just flip it upside down, I guess. Okay. And then water starts moving around the tube, apparently. This happens because of the Coriolis force, which is, as we know, defined as F Coriolis equals 2mv cross omega, right? That equation looks familiar. Concretely, the consequence of spinning the tube is that the water has some speed, or more precisely different parts of the water mass have different speeds because they're different distances from the axis of rotation relative to the Earth, and then the Coriolis effects takes, or Coriolis force takes effect. Okay, I think. So, right. Yeah, okay, so vector x south, y was EC radially. Then okay, then you write angular velocity in this frame. Oh, Skullmeat, welcome back. And so where is flat Tamaki? Sorry, is that a joke we had before? I kind of forgot what it was. Although I don't know if I mentioned before, but I'm working on a character model update, and it's actually I've hit a bit of a roadblock because I don't know how to shade hair for shit. I'm a little bit relieved in knowing that apparently there's a lot of illustrators that have trouble with hair, so drink number 4. Oh, by the way, Skullmeat, let me see if I can pull that tweet out. You know that oh crap, I closed the stream manager. You know that you know that energy drink that had like here, let me pull up the tweet. You know the Zone, that energy drink? I think you linked it before, or at least it looked familiar. Yeah. So I didn't. So this this tweet went out yesterday, but apparently Shigure Ui, you know, the illustrator for Old Sora Subaru, she did art for one of the like, or she did art for it, is I guess my point. So there's a tweet for that if that interests you at all. I was just kind of surprised because you look at it, you look at it, and it's like it's her style, but it's very like distinctly different. Like I didn't, I've never seen her draw like that, so it was just something that caught my attention. But anyway, yeah. Want some to make you feel a little bit worse, they're doing Lawson is doing the Lawson, the convenience store, but they're doing the whole point of that illustration is they're doing a limited time campaign where I believe you can get a sticker of the illustration along with your drink. Yeah, I wish I was in Japan right now, but anyway, yeah, whatever. Yeah, let's rehydrate a little. Oh, okay, here's a better diagram. Okay, so that's how you're spinning the ring, or that's how you're spinning the generator, whatever it's called. Okay. Or do I have this right? So, okay, so theta is the... No, whatever, that's the position of the... We're using theta just to figure out what... or figure out the cross product of the omega vector and v, so that's theta, so that's why they're using a different variable here, or, yeah. Okay. Still not quite sure what is going on. Yeah, but whatever. So if we do those definitions, so even though I don't know what the hell is going on with the actual tube, at our where the hell on the globe we're standing, we can use that first definition to establish what the omega vector is. Okay. Yeah, and we can use theta to define where on the Earth we are. Okay. Yeah. We use two angles to describe the position of the point on the ring as seen in the non-rotating frame. Phi is defined as the angle between x and r. Okay, yeah, so x was defined as south. Y is east. Okay, so south, east. I'm trying to do it with my hand right now. Oh, Opponent Trash, welcome back. How you been? Okay, so x is south. Y-axis is east. So okay, so we're actually kind of looking at it from like inside the Earth here. And R is the position. Okay, so R is like where our arbitrary piece of like water inside the tube is. Oh, okay, so that's what this circle is. This circle is the water in the tube, essentially. Okay. And then what? So I guess that means if y-axis is east, then we are spinning it like if we took a donut and then we like stabbed it in the side to make sure it went through the middle, and then we spun it around, or yeah, so like we took like a kebab like stick or something, and we stabbed the donut through the side, but went through the center, the open center of the donut, and then out of it, and then we spun it along or around that stick that we shoved into it. The stick would be the y-axis, and then we flip it over 180 degrees, so it's upside down. And then when you do that, you're supposed to get some movement of water inside the tube, which is the donut, so to speak. And the question is, what is the velocity of that, I guess? I've been doing good. How about you? I am behind on a lot of things. I also totally bombed my exams from 2 weeks ago, but we're just gonna keep looking ahead. If I had time to be all depressed about it, then I have time to study. Although today I think I'm since there's nothing immediately to do, I'm just gonna focus on trying to understand this question, and then Yeah. So I'm not really going to look at the actual work. I'm just going to look at the setup and see if I can figure it out from that. Anyway. All right, so that's what we do. Flip it over once. Okay. So then our R vector... What do we do with the... Oh, so as we flip it over, we well, first of all, we have an equation for the R vector then as we flip it over. And we also have an R dot vector, the change in R over time. And I guess with those two values, then we have an equation, I think, somewhere. Or we have the equation for the Coriolis effect. We can literally just shove it in there. We convert V into R dot, and then we can compute the cross product, I guess. And it looks like that's... Oh, okay, they do another extra processing where they just take the tangential component because that's all that's relevant to the movement of the water. My trash dam, alright, I'm gonna head out. Alright, yeah, sounds good. Thanks for coming by. Take care, stay safe, and yeah, see you later. Okay, so... Okay, so I think that's what it is. So let's check. So phi is defined as the angle between x and r, and alpha is the angle the ring makes while spinning around the y-axis with angular velocity alpha dot. Is that necessarily true? So you have that angle. How do we know that's alpha dot? Well, no, oh wait, actually, no, that's stupid. Of course we know it's alpha. If alpha is literally the angle that the ring makes, then the speed at which it changes should just be the time derivative. Yeah, time derivative of it. Okay. So then they express R, okay, in terms of the local coordinate system, and then they sub in the actual angles that we were given. So it'd be capital R, the length of it multiplied by cosine alpha sine or cosine alpha cosine phi. Let me double check. So if you have the R vector here, alpha is between R and X. So the X component is R, capital R, the magnitude times cosine phi, right? That gives you this length. And then, sorry, let me think. So, Okay, well, I know why y doesn't change. It's because r sine phi, yeah. No matter where during the spin you're pointing at, that's just going to be that height. Right. And then the z component, why is it cosine phi? I think I need to draw this. So, okay, so, alright, so y, x, z, we have the disk, and it's like this. And then it rotates like around the y-axis. And when it does, you have some point that essentially draws you essentially have a or a point that moves along a plane that's parallel to the xz plane. Okay, so we know that. What are the definitions? From x and r, so let's just take an arbitrary point like that. Call that the r vector at some point during the rotation. So the z component is going to be, and wait a sec, so r, oh, it's coming, found a US seller of zone. Oh, really? How expensive is it? And I guess the question also is, though, does it come with the goodies that you get in Japan if you order some? I mean, you know, not that that's the only reason to buy it, but that's kind of a big reason, right? So, okay, so you have the r vector there. Phi is the angle between x and r. Okay, so you have x and r, and then if this is like, it's like this, like this is the plane. And which plane is it then? Yeah, I guess this is the angle then. So this is going to be alpha. And, or phi. This is phi. Alpha is the angle the ring makes while spinning around the y-axis. So then it's this guy, which is alpha. Oh wait, that angle shouldn't change then. What's wrong here? $40 in shit. Oh shit. I mean, I guess for a drink, that's, yeah. I've had to pay like, you know, $20 in shipping just for a book before. So I guess $40 in shipping for like, I don't know, a 12-pack or something probably is understandable. You're gonna do it though. Are you sure? Like, make sure you. Hopefully, you can get some of the goodies though. I don't know if it's stickers, or I thought they used to do like a postcard too. But anyway, hopefully you can get some of those too. 3 to 5 days. Wow, if it actually arrives in 3 to 5 days, I'll be impressed. Right, anyway. So they don't really draw alpha here. They do draw phi. So I think I need to hold one of these variables constant then. So phi. Okay, so let's say we hold phi constant. We're gonna lock phi in a certain position. How do we do that? I feel like I'd have to draw it this way. How do we lock phi? How do we lock phi if we're spinning about? Oh wait, no. Okay, so that's what this diagram's about. Okay, $60 for four cans. Wait. Are you sure? I mean, I guess okay. If you wanted to, I really hope they give you some stuff because that's pretty. Yeah, but that's still pretty steep. Oh jeez. I mean, I understand it's a drink, so of course it's gonna be expensive to ship. But like, damn. I hope they better package it well then. Like, imagine if it arrived, but like one of the bottles like punctured or something. They better not damage it. But anyway, so okay, so I guess if we're gonna copy the diagram on Slater, then it's like this, and then X, Y. Yeah, yeah. Let us know how it tastes though, cause you know I've seen, you know, it pops up in my on you know my Google ads every once in a while just because of all the illustrators um that collab, but um yeah. All right, wait, no, this is an A. This is alpha. Okay. What's worse if I like them? Yeah. Well, I guess if you like it, that means you'll be able to buy it in larger bulk. So I assume in the long term you'll conserve some money through shipping, um, or if you just like buy a pallet or something. That would be a little excessive, but yeah. Okay, so right. So if we're rotating about the y-axis, so it's gonna be like dot 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 dot. These are where it travels through. Yeah. So the angle with the x, I guess z plane. Not that they specified x z plane, but I'm going to. So yeah, that angle will not change. Well, the one thing I'm a little bit iffy on is why the angle at the x-axis doesn't necessarily change. Because couldn't you define a new plane that's like slanted for which phi is larger? Angle between x and r. Oh, this is the website? Zone Sugoi-mart. They're really leaning into that name, isn't it? Aren't they? $5. I mean, I guess, right, like $5 by itself, I guess, isn't that bad. It's just the fact that they hit you with shipping, right? Like $5 for trying a drink isn't at all bad. I would try asking them about the goodies that you usually get with Zone, because I'd hope they include it. I don't know if there's a place to ask about it, but yeah. Yeah, that's good though. That's good though. Especially good to finally see what the whole deal is with Zone. Okay, so is that really fee the entire time though? That's what I'm iffy about. I understand if it's okay. So if you had fee, so like when it's flat like this, you're in this flat plane. Of course, the angle's phi. But as you move out of the xy plane, why doesn't the angle phi change? Oh, wait a sec. Is that just it? Is it because we're actually rotating the entire frame? Yeah, okay, yeah. So if we just leave it and we just rotate the entire frame, or along with the torus, then it'll still be spinning about the y, but phi will stay locked. Okay. Okay. So then you draw this arc. Okay. And that arc is the position function r. Okay. So then the components of that function should then be r equals, let's see, x component is going to be r cosine phi, and then we also need another term to figure out how far in the rotation it is. Let's see. Alpha is the angle that the ring makes while spinning around the y-axis. The angle it makes while spinning, so I should draw the y-axis a little bit here then. This is y, you got x over here, and then you got z over here. And you've got this alpha that you get out of rotating it. So the x component of this would then be, how do you guarantee it's cosine phi? Oh, they have other flavors? Oh, do they? Sorry, I only glanced at the page. Yeah. Okay. Well, yeah, that'll be good. Yeah, as long as if you're gonna spend a lot of money, you might as well get a couple to try, right? Yeah. Hopefully they have like a. So. Yeah. Well, anyway. Yeah. Still having trouble with this question though. What is going on with it? So you rotate it. I'll let you know how it is. Okay, yeah. I've been really curious because, so we'll see if it's, if it's all, that it's hyped up to be. How do they get? Or actually, wait. So I got the cosine phi. I'm wondering where the cosine alpha comes in. Like, what angle is the cosine alpha portion? I guess if it's purely just like this, I wish they defined these a little bit more clearly. Yeah, like if I hypothetically just labeled it at, alpha equals 0 is where x equals, or where the vector is right in the plane of the xy plane, for example, then it would be cosine alpha. That would be the x component. Yeah, so if that's, okay, so then you'd have cosine alpha. The y component is just our sine phi, because it's just how much it's sticking in the y direction. And then the z component should also change though. It should be our, there's gonna be a sine phi in it, or no, sine alpha. And then it should also take on, let's see, how much of it this is in the, I guess it's cosine phi actually. Yeah, cosine phi will tell you how much of, cosine phi and then sine alpha should tell you how much it is in the z direction, because our cosine phi will essentially, if it rotates 90 degrees, then that is the z height. So to make sure you get that, but not a no z value when you're in the xy plane, you need a sine alpha. So is that right? R cosine alpha, or cosine alpha cosine phi, R sine phi, R sine alpha cosine. Okay, finally, did something finally right. Okay, so that is the right position. Okay, so then from there we can just take the derivative with respect to time, noting that the only variable here that changes with respect to time, we're assuming phi is constant per iteration. You know, assuming we're on some, well, yeah, assuming phi is constant. I guess we're looking at one chunk of water again. So for the given chunk, its phi will be constant, but its alpha will change as you rotate the ring. So then all these alphas turn into get the derivative applied to them. So r sine phi should go to 0. Yeah, 0, because there is no change with the respect to time. We get r cosine phi is our constant. Cosine alpha derives into negative sine alpha with an alpha dot outside, and r cosine phi again. We get a cosine alpha and then an alpha dot. Is that right? So negative r alpha dot sine alpha cosine phi, yeah. 0 r alpha dot cosine alpha cosine phi. Okay, so I think, and this is the exact reason why I don't do well on exams, right? Even with a diagram and explanation, it literally took me 40 minutes to understand the problem. which is I guess the reason why I guess the strat next time around is I need to have just like a list of every possible, I guess, diagram they could give me, you know, within reason. If there's something beyond that, then I just have to say, like, well, fuck, I'm screwed. But I should just have a bunch of diagrams ready, because clearly the wording isn't descriptive enough to really help me anyway. Okay, so anyway, we can write the Coriolis force now, because Coriolis force was, it's like, I think it's 2m r dot cross omega. Yeah, it is. Okay, so it's 2m r dot cross omega, so we could compute that cross product, I think. Well, actually, we need omega, which I think we were supposed to do in a previous step, but yeah. There we go. Actually, I just remembered something. I've been meaning, just because I've been so behind on the Operation Meet Yago thing, I was going to at least start by actually backing up my stream VODs to YouTube, so let's actually start doing that. I have a buying dinner stream that's expiring in a day. When did I do that? Whatever. Download. Actually, I got one stream here that's got like double the amount of views as usual. What the heck happened on that stream? Whatever, we'll see. Actually, why are there so few videos? 1, 2, 3, 4, 5, 6, 7, 8. No, never mind. They're exactly the correct number of videos, actually. Yeah. Okay, so anyway, we need an equation for omega. So we need to, we need to define the circle that or the sphere that we're on. Yep. Oh, that downloaded fast. And then x is to the south. And we have omega being the rotation of this on the Earth. Okay, so then omega, I guess, the rotation, knowing that this is going to be angle theta here, we're going to get in terms of XY coordinates. The XYZ. The Y component is always 0. Okay, so we set the coordinate system as in the picture above. The vector X, points south, Y points east, and Z points radially from the center of the Earth. In this system, the angular velocity can then be written as negative omega sine theta 0 cosine phi. The Y component is always 0. In fact, they only needed theta and they only needed theta. Where angle theta is the colatitude of the tube. Okay. What is colatitude? I don't remember. Complement of the latitude, the difference between latitude and 90 degrees. Ugh. Complementary angle of a given latitude. Okay. Okay. So how do I know that's the X component? So the Y vector points east. Why is it 0? Why is it 0? Well, let me take negative omega sine theta. Okay, you know, I think I'm thinking about it wrong. It's the angular velocity. So I should have an equation for the angular position and then just take the derivative of that, right? So that would be Oh, I must have been kind of excited. Yeah, I mean it's the sports drink that or not sports drink, the energy drink that you know we've heard about so much, right? Thankfully, it's not taking like weeks to arrive. Although speaking of that, I'm still waiting for something to still waiting for that BlackBerry keyboard from or that BlackBerry keyboard breakout from Sweden to arrive. So we'll see when that arrives, whenever the hell that's gonna be. Probably should order some like scratch boards or something before it arrives. But DHL Express, okay. So it's 3 to 5 days, and I guess they're usually pretty on or correct in terms of lead times. So yeah, that'll be exciting. That'll be fun. Hopefully it arrives. Well, actually, it's still Tuesday, so yeah, it could potentially arrive over or before the weekend, or right when the weekend starts. So that'll be interesting. Let's see. That'd be cool, right? Well, maybe we shouldn't. Maybe not. Sorry, I shouldn't have said that because I don't want to get your hopes up and then like it end up arriving like on Monday or something. But that'd be hopefully. Can't for a close round though. Okay, so yeah. Well, I mean, again, as long as it arrives in one piece, right? Yeah. All right. So angular velocity, right? Circuit angular velocity vector. Let me just see. Oh, what is the usual setup? I keep forgetting this stuff. Okay. In this system, the angular velocity can be written as this. For some reason, the y component is 0, which means that before you got the velocity, the angular position vector must have had either a constant or also 0 in that spot. Excuse me. Let's see. The only reason why I could say that must have a constant velocity. Or sine theta, actually. Solution to the problem starts with projecting omega to a Cartesian coordinate system and rest at R. For omega prime equals that transposed. Oh, wait, this top thing is just the omega vector then. Okay. So what? Oh, okay, so I can kind of see by this description, y is always 90 degrees to omega. So I can see why then that the omega vector must just not have a y component. So you have omega x next. First of all, it's pointing relatively down. So how do I get this? So maybe I should rotate it like this. We have the omega vector, which is like, in some sense, it's pointing like part of the way in the x and y. So take sine, or no, which angle is this? We have this angle, which gives us this angle, theta. So judging by that, then the omega z component is then the cosine of theta times however big omega is. And omega x is then the negative sine, or omega negative sine of theta, because we want the flat, the open end, but pointing in the opposite direction. Is that right? Is that how they derive it? Negative sine omega 0 cosine theta. Okay. Or negative sine theta, but okay, finally we're getting somewhere. Okay, oh, what is this new wallpaper? Okay, let's see. Nice. Is this... The art looks familiar. Is that someone you... Is this by someone you've linked before? Should zoom out a little bit. Well, the one thing I do have to say is what do you call it? It's this grainy effect. I want to know what texture they use to get this like grainy effect going. Yeah, I know I see a lot of people use it, but I'm not quite sure what tool or what it is. Yes. Okay, let's see. Oh yeah, and I am followed. Okay, yeah. Oh yeah. Okay, I remember. Yeah. Okay. Right, so we have omega and we have r. Both, actually wait, no, they're not in, well, we have the components of them, so we could take the cross product of them all. We have the components all in terms of the xyz coordinates that are spinning around and such. Okay, so we can write the Coriolis force as all of that. Apparently it simplifies really... Oh yeah, it does simplify really easy because you have two, like, zeros. Okay. Okay, so they say what matters for us is the tangential force because that's the component that moves the water around. So the tangential force, I guess, must be... We get it by multiplying the Coriolis force by cosine phi. Cosine phi. Cosine phi will give us the force in the y direction. We can also take the average of this acceleration, because by doing that we get rid of the phi dependence. So you get the acceleration of the tangential component due to the Coriolis force equal to this integral. How do we get that integral out of it? Put the Coriolis force in and then multiplied it by cosine phi and evaluated the phi integral for an entire rotation. Okay. Oh, I see. So the only ambiguity I have, I guess, is where the whole justification of only needing the tangential force. I mean, mathematically, that's the only thing left, but okay, whatever. So mathematically, we would just shove that into an integral evaluated over 2 pi, the rotation of phi. Oh, actually, wait, phi doesn't rotate 2 pi. It only rotates pi, right? Huh? I'll get the third one downloaded. Why is it 2 pi? Why is it 2 pi? Or is 2 pi for the... Let me think. Phi is defined as the angle between x and r. X and r. And alpha is the angle the ring makes while spinning around the y-axis. Yeah. So this should be the ring in the flat plane. And phi... No. No, alpha is pi. Why is phi 2 pi though? Oh yeah, right. Phi is 2 pi because it has to... You have to evaluate over the entire disk. Okay, yeah. So that is 2 pi. Okay. Right. And then we're divided by 1 over 2 pi for some reason. I don't know. It's like a normalization factor, but something. 2m. So we lost a 2m, we gained a 2 pi. Or 1 over 2 pi. Alright, so they must have used f equals ma, which equals 2m r alpha dot omega cosine phi sine alpha minus theta y hat. Okay. So then m cancels from both sides. You get a equals 2 r alpha dot omega cosine phi. Yeah. if you take the expectation value of that, wait, which class was this? Is this 105 or 137? This is a 137, or this is a 105. So we never learned how to do the expectation value here, right? So how do we get the 1 over 2 pi? It's not like a normalization factor provided by the okay. Speed line correlation to dt. Oh wait, close multiplied by cosine phi for some reason. Why was that? Cosine phi gives you the component only that cosine phi. Cosine phi as it's defined now would give you the south facing component essentially. Is that right? So okay, so the Coriolis force is a purely y component thing. And we use cosine phi, which is why is that necessary? To get the tangential acceleration. Tangential. How do we know? How's that necessarily the tangential component though? Because it's phi. Let's see, tangential. I mean, I guess x and y are both tangential to the rotation. But then leaving y alone should be fine. doesn't make sense. You'd need to take tangential force of the Coriolis force is what moves the water around in this case, apparently. So the tangential component of the Coriolis force is what moves it around here. Moves the water around here. Okay. Okay, so I get the average part. That's just observing that cosine phi has, or cosine squared phi is just 1 for evaluated over phi equals 0 to 2 pi. Right? So purely from a complexity perspective, it's just more convenient to just get rid of that phi. Okay. The question is the previous justification of, well, actually, wait, 0 to 2 pi. We didn't need the phi there to necessarily get rid of the phi dependence. Wait, cosine phi. Which vector was that? Cosine phi. Cosine phi. Cosine phi went into the x and z vectors. Right, so how is cosine phi the tangential component of the ring? Cosine of phi. Cosine of phi. Cosine of phi gives the x component, essentially. Or no, not necessarily. Cosine of phi is pointing like here down at this spot. It's this component, it's down component. So is that necessarily the tangential component? Oh, the fourth video downloaded, okay. One, two, three, four, five, or 1, 2, 3, 4, 5. Here we go. Download. Cosine phi, cosine phi. Oh, I'm a freaking idiot. Yeah. If the Coriolis force only has a y component, then no shit the tangential component is just multiplied by cosine phi. That could be either the x or the z axis, or really anything in the xz plane. But whatever, no shit, any vector in that would be tangential. Yeah, okay. it's this, it's like I knew it was gonna be a straightforward conclusion, but like because literally in the line before we're literally talking about the Coriolis force component only having a y component in our frame, and I was like, why is cosine phi necessarily the tangential component? I was like, should have, and it took a while of glaring at the I didn't make the connection that cosine phi is basically anything in the xz plane, but right. Okay. So then the Coriolis force multiplied by cosine phi is then the tangential component of the Coriolis force, which I guess is the only part we really, well, right, the non-tangential component isn't moving the water. It'd be the equivalent of like pushing the water to the ceiling, which I guess in some sense might like push it in away from the point, but like that's included in the tangential component. So right. Okay, I still don't know where this 1 over 2 pi comes from. I imagine again it's just some like normalization constant. Yeah, so then they also compute the average of acceleration using again f equals ma, and then you can just cancel it. You get a equals whatever using the Coriolis force inside of it. Obviously the expectation value, so you're going to take the integral over every position, which is going to be d phi, and you should end up with some answer. And then they say we take a look at the increase in, well, you have acceleration, so if you just integrate the average acceleration then, or oh, Konosuba, welcome back. Yeah, okay, so they say dv, the infinitesimal change in velocity, is equal to the time derivative of the average of the tangential acceleration. Is that an identity we need to know? Or wait, no, that's just it's that integration technique, right? It was really dv dt equals a, and then they just moved the dt to one side, and then presumably yeah. So that was just dv dt equals a to some degree, of course, in this case the expectation value. So we're going to retain that notation for the sake of convenience, and then you can do dv equals the expectation value of a dt, and then therefore you should be able to integrate both sides. So v equals the integral of the expectation value of a with respect to t. Because a dot dt equals dA over d, a dot, or alpha dot equals d alpha over d, wait. Alpha dot is d alpha dt by itself times dt, so d alpha. Where do we get alpha dot? Oh, there's an alpha dot inside the integral. Okay. Oh, okay. So there's an alpha dot inside the integral. So we use alpha dot dt equals d alpha dt equals d alpha as justification for converting this integral from an integral of time to an integral of alpha. Okay, and then you should, okay, that makes more sense. Sort of. I feel like I stumbled my way through the entire thing, but at least I feel like I understood it. Okay. So, I think we're moving to Project Yago. Should I be doing this so much this week? Probably not, especially since I got my grades back. But you know, we're gonna do as much. Well, I mean, you know, I'm not gonna be able to do it after the 25th, so we're gonna give it a shot. Mirai Akari's new outfit. Man, Mirai Akari's one of the OGs, right? What's her new outfit like? Or wait, is this the one from a couple weeks ago? Or maybe not a couple weeks ago, I don't know. I haven't seen it, but I don't know when it's from. Maybe it's this one. It's a very small picture. I'll look it up later. Yeah. Alright, so we're gonna go straight back into Operation Meet Yago. Because we're perpetually behind on it. But I did make some progress actually. So move this lamp a little bit closer to my face. Okay. Let's get rid of which layer was this layer, I think. Yeah. So we're gonna oh, that's nothing. Okay. Screen mirroring, please work. Akari full. Okay, let's see. Oh wow. Who's the artist for this? It's really cool actually. It reminds me of like it just mirrors it a little Vocaloid-ish. I don't know. Well, maybe not Vocaloid. What does it remind me of? Whatever, it's cool. It's cool. I like the I like how they mixed in the butterfly, you know, thing into the whatever the hell you call it. Again, screen mirroring is not working. Come on. Let me just work on it off screen. I actually I actually stayed up pretty late last night. I couldn't really fall asleep and I forgot to take the sleeping aids that I usually do, so. But in exchange, I made a decent amount of progress. Well, actually no, I didn't make any progress last night, honestly, but I was able to make some decent progress overall since yesterday with like shading the hair, so. Well, maybe not decent progress, but I figured out how to get the look right. Or I figured out how to get the like the diffuse reflection of the hair to look right. So that's step one. Still not connecting. And just restart the app at this point. Oh wait, it connect. right when I closed it, it decided to connect. Mind is in the gutter. That's kind of what alcohol's supposed to do, right? Sounds about right. Yeah. Okay. So I guess if anyone's interested, what I'm going on about really, it's this. And you can tell that my iPad's still laggy. I still need to, well actually wait, why does this look right? Oh, it's because I haven't really edited everything yet. Okay, yeah. So it's actually this that I thought came out really well. This like loose highlight, and it's like I know the technique that they use, but I think I finally got it down close enough that it kind of looks like it. It's you use the dense water. I did it with the dense watercolor at max hardness, and you just kind of like, well, I made like a big blob, and then what most people do is they erase at it to make these kind of like M slash like these jaggedy shaped things. Of course, I'm saying this mainly for my own reference, so I can look back at the VOD and be like, wait, how did I even do that? But yeah, so that seems to be the technique, and I got it, I think, pretty close to what it's supposed to look like. Looking at Mirai Akari, and I'm like, I'd fuck that. I think Mari might have rubbed off a little bit too much on you. Or again, maybe it's the alcohol, maybe it's sencho, but okay. So right now I'm looking at Debimaru, the illustrator Debimaru, and I'm mainly looking at how they do shadows or the shading on the hair. Yeah, because like as much as like I'd like to leave it like there's not as much like it's too light. There's not enough like depth, I think. Actually, so that's one thing I wanted to test. There's one trick that some illustrators use to make their drawings look a little bit brighter, and that is to actually make the hair near or on the underside of the head actually brighter than it's supposed to be. So it'd be like making this hair right here actually lighter. So this is one, oh, that's not big enough. This is actually one thing I wanted to test. And of course, right now all I'm doing is just demoing the color. Basically, my plan is to, I'm doing these on layers that are being clipped, and after that, after I get the colors right, I'm going to duplicate the layer to each component. You know, because this is for live 2D, right? There's tons of layers under this, and I'm just kind of, you know, drawing over right on top of all of them. But after the design's ready, or after the color, I guess, is decided, then on this clipping mask, then I can just duplicate the clipping mask. I realize that's the strat to saving time. Because otherwise you'd have to like painstakingly. Should I make it lighter? Well, let's try it like this. I also ended up changing the brown of the hair to be a little bit more pinkish. Just thought it was a little more interesting. Also, I've been watching Horimiya, and I realized Yanagi from Horimiya actually has hair that's a little bit brighter than this color, and it kind of made me realize, like, yeah, you could totally do that. You could totally do that and get away with it. So I was like, yeah, it's kind of like yeah. So yeah, you see how just that little brightness there kind of made the hair, or the kind of the face a little bit kind of, or the hair kind of a little bit lighter, or so they say. So I think we're going with that, except here. So we have, what is this? Oh, my screen's not even visible, whatever. So I'll just name them. Debimaru, I'm looking at Debimaru on Pixiv's illustrations, and they're very, he, she, I don't know. They are, they go a lot harder with the light color in the back, and it actually works. So actually, we're gonna try that. I would mix in orange, but I realized that since the skin is so close to orange in the first place, I want to mix in orange because of the eye, but it's just like, I don't know how to get it to work. Oh yeah, like that. Well, actually, let me boost the brightness. I want to see that works. And once I put it on the right layer. I gotta hurry up and have. Okay, wait, nice. I know one thing I need to do for sure. I don't know what layer it'll go on, but I guess it goes on this layer. First of all, I don't think this layer works, honestly. So we're getting rid of it. Bye-bye. One thing I do need to do for sure is I need to add more detail in the hair in the top. I think. Yeah. Like there's too much space here. Like obviously hair exists there, but there's not enough stuff going on there that it looks too empty. It doesn't look right. So we're gonna start adding some details. Oh, you know, I know how to do this well. Let's go to Pixiv again. Okay, you know what, never mind, I'm not even gonna comment. My computer screen is invisible. Okay, so I can have this on full screen. Following. Not, no, Tokyo, Scotty. You know, Scotty actually has a really interesting way of drawing, or shading, so let's pull up Scotty's stuff. That's not who I was thinking of. Mm. やっぱ二重にやる場合もあるのか。Yeah, but no, let's use Jade June has a pretty, it's got like a digital look, but that's actually what's good about it. So, and even they don't do that. Okay. Yeah. Okay. Yeah. So we're gonna just kind of BS it. I think actually with a different pen. First, I want to add all this crap that. Actually, wait. Yeah. Okay. I honestly don't want that much detail. Accidentally post Mel's dick sucking. I think I think you need to either lay off the computer or lay off the alcohol. Dude. You're gonna get banned sooner or later, dude. Oh, how about Hatsuko? In fact, I have one of Hatsuko's books as well. Yeah, this is the one that was released around the end of the Kemu Vox circle, or the one, you know, right around when they finished their activities. There was a Discord I've been in for ages, and the owner said, "Dude, you posted in general." I mean, I guess he was nice enough to let you know, but yeah, maybe have a. Oh, dude, you know what would be hilarious if you had like a breathalyzer that was, you know, like but like linked to like your computer, and like whenever your alcohol level is too high, it switches your keyboard predictions or whatever, maybe like switches which emotes you have accessible to you or something. Like that'd be such a, well, that'd be such a dumb thing, but I feel like that'd be hilarious to have. It's like have you make your computer make a like a keyboard that stops you from posting certain emotes when you're drunk. Yeah, okay, so Hatsuko, you know, Hatsuko's the same, or in the sense, not the same, but like literally, but the same in the sense that she has a very digital look to her style, which is why I think she can add a bunch of like really well defined like scratchy kind of lines and still be fine. Although it doesn't look like she uses the G pen. It's clearly some kind of like emulated pencil. Yeah. And in her case, I feel like, yeah, it's hard to tell. Something, I feel like the light source is totally random in a lot of her things. But yeah. Should we draw anyone where you can clearly see there? Okay. Oh, okay. So so the way Shigure does it for the most part is, it's a darker color of the hair, but it's not like the line art color. She generally draws softer, so that makes a lot of sense. And sometimes she just uses the shading to convey where exactly the root of the head is. So let's take a book from her. Or let's take a page from her again. So like here, instead of drawing little crap here to show where the base of the head is, I guess following her logic there, you would instead probably take the watercolor tool and maybe like brush a little shadow, a light shadow. In fact, I probably shouldn't even be using this color. I should be using like that one or something. I actually couldn't fall asleep last night, and I went back and watched Shigure Ui's, which one was it? It was the one where she had to stream as her loli form, and she was drawing fan art for can't remember who it was. But like I realized, like, I mean, I guess I already knew this, but like it's kind of just more like reaffirmation. But her streams are like a gold mine for like information in terms of like learning how to get better at drawing. Like, not exactly the look I was going for actually here, but I think that's the strat. Yeah, so I think I should probably just get back to what my initial idea was, which was... Oh, something froze. There we go. Okay. So So we want to add some like interesting lines here for this is an empty layer, right? This is an empty layer. Okay. I want to add some interesting lines here. Other studying. Oh yeah. Okay. Hey, it's sort of studying, right? I studied Shigeru Ui's stream for like 6 hours last night. Yeah. And actually while I'm well, hey, I did one problem. I did one problem on the for analytic mechanics, right? So let's see. 1 2 3 4 5. So I need to add 1 2 3 4 5 6. 1 2 3 4 5 6. Sorry. I'm actually also backing up my the VODs that Twitch hasn't deleted yet. So I'm gonna have to stay up until all those downloads finish anyway. But yeah, like I don't know, anyway, so so this step is usually referred to as or at least what I'm doing is kind of duplicating the step that is usually referred to as like the, it's the step where you put in your harshest shadows. Some people say they do it for augmenting the line art, which is kind of mainly the use I'm going to be using here. Or at least that's what I'm going to try to do. We'll see if I can actually do it, considering how much trouble I had last night. But yeah, the idea being that the shadows aren't there to really be shadows, but more to say, it's more to help the line art be like, here, this is where this is where that is. So in this case, for example, it's establishing a clear hierarchy. This middle piece is the top tuft of hair. This one is the one below it, that one's below it, so on and so forth. Unfortunately, it made me realize, and I'm sorry, this is more, I guess, so my vlogging tag is totally correct, because this is really just like self-documenting. You can tell I've done a little bit of coding, but yeah, if I'm self-documenting using my stream, but yeah, like there's not enough variety to my hair. Granted, I've been drawing the same hairstyle so much, so no shit, but more specifically that it's always the middle strand tends to be the highest one, and then I tend to draw outwards from that, regardless of what direction I start drawing from. So it made me realize I need to kind of boost my the variety in the way I draw hair a little bit more. Like hypothetically, you could draw from the bangs and then go inwards or something. And that's something I occasionally do, but I rarely add that to the hairstyles I draw, so that'd be some much needed variety. I don't know if I want that shadow that big. Yeah. So as much as I'm tempted to add a lot of shadows, I'm not. So once we got that look there, then the question is, we need to clear up this emptiness. So Alright, so one thing I should totally do is we can use these to kind of hint at which strands of hair are above and below. Should I use different? No. Oh, have you anything to drink? Me, nope. Yeah, just feign ignorance. They'll let up at some point. Yeah. Yeah. As long as it's not harming anyone, right? Well, that's an interesting shape. Like that's actually looking. I mean, does it look good? Not really what I was thinking of, but it's getting closer to what I was looking for, which is comforting, I guess. I better save if I forget. I've reached the point where the app does crash. I've reached the point in this update where Clip Studio Paint actually does crash from, too much load. So I actually have to be careful now about saving. Yeah. Hmm? Oh, did this? Oh, it's fully charged. Okay, that's what it is. Okay, let's add more detail down here then. 네.どこもっと暗くする。 Oh wait, it's already past 11 o'clock. Alright, so I should call it a day pretty soon. Especially since it seems like we're making some decent progress. Still behind, but yeah. Yeah. I think that's what I'm gonna go for. I'm gonna put another layer of that kind of watercolor, dense watercolor stuff on. And then the hard highlight, and I think then I'm done with the hair, so almost there. And then I gotta apply it to every layer. So yeah, let's see, I don't know who's left. I imagine it's probably Skull Meat and anyone else that's lurking. As usual, the stream manager doesn't really actually give me very precise information, so it's never easy to tell who's actually here. Let's see, 1, 2, 3, 4, 5, 6, 7. All right, yeah. So I've downloaded 6 of these videos, so that should be good for a day. Yeah. Right. Anyway, yeah. So everyone, thanks for coming by. Take care. Stay safe. Have a good evening. Tomorrow is Wednesday. I'm just thinking, man, that deadline for the application is winding down. Anyway, we're gonna do our best. So anyway, yeah. So everyone, take care, stay safe, have a good evening, and take it easy. お疲れ、おやすみ、終わり。